Hello friends, welcome to Power Electronics. Today we will discuss the voltage commutated chopper. This is one of the earliest chopper circuit which has been very widely used in the voltage commutation. So this chopper is used in the very high power circuits. But condition here is that where the load fluctuation is not very large. Load fluctuation should be minimum. So what we called it, we can call it as a parallel capacitor turn off chopper, or we called as impulse commutated chopper or classical chopper. These are the various names of this circuitry. Where C here is the capacitor. How do we charge the capacitor? First of all, we must know the conditions to charge the capacitor. If you look at this circuitry, you can see here T1 is the main thyristor, TA is the auxiliary thyristor, and one diode and L, that is inductor, is connected. Also it is connected with the freewheeling diode, and load is RLE type, where E is the DC battery. So how we can charge this capacitor initially? These are charged by the two methods. There are two methods to charge this. The first of the method is that if we just on this switch, the supply voltage starts flowing through the capacitor and has a return path through this resistor to the back path. So capacitor will get charged. When both these values are charged, that means the capacitor is charged with the supply voltage, then the charging current is equal to 0. That I have already discussed in the various classes. So this capacitor gets charged. One of the another method to charge this capacitor is by what you have to do here, just trigger out the auxiliary thyristor TA. When we trigger it on, it behaves like a short. So the supply current flows through this capacitor, start charging it, and then flows through the auxiliary thyristor, then to the load current, then through the load RLE, and then goes to the back path. So there are two methods of charging the capacitor initially. So we will discuss how it works. So in the mode 1, there are 4 modes of the operation, and we will discuss one by one. The main thyristor is triggered at t equal to 0 time, with RLE load gets connected across the Vs, that is source. Then the load voltage is equal to V naught is equal to Vs. So when it is connected, then the output voltage V naught is equal to the supply voltage. During this mode, there are two current paths. What are the various current path? First of all, this one T1 is get triggered, or another path that current flows through this path and passes through the inductor, diode, and then return to the capacitor. So there are two here path of for the current flowing, that is the current flowing through the RLE. This is the one of the path, and another path is that it flows through here to the inductor, then through the diode, and then again back to the capacitor. So during this mode, the two current paths are as you can see. The load current I naught assumed to be constant. Why it is constant? Because T1 is already triggered, so the current is flowing through the load. So load current I naught flows through the Vs means and through the T1, and the load where the current IC, that is charging current, flows through the oscillatory circuit formed by the capacitor, then through the T1, and then through the inductor, and the return path is diode. The capacitor current rises from 0 to maximum value when the voltage across the capacitor C is equal to 0. So this is how it works. In the second mode, you can see here in the first mode how it changes into two parts. First of all, it passes through RLE load and also through the inductor, diode, and capacitor. In the second mode, you can see when the capacitor gets completely discharged, it changes polarity from here plus minus to here minus plus. So it gets completely discharged, and also the auxiliary thyristor gets off. So here when the auxiliary thyristor gets off, also the diode, you can see that how the diode is connected here. Diode is connected like this. So this, if this is positive, that means the diode behaves like an open circuit. So there is no path for current flow, only one path is available in the mode 2, that is it flows through the load RLE and to the back path. So that means what happened here? That means what happened here, that the supply voltage, that is minus Vs, if you apply KVL, minus Vs and minus Vc equal to 0, that means that charging capacitor equal to minus of the supply voltage. So you can see that load current is constant, as you also can see in the diagram that it is triggered here, Ig1 is triggered here, but the load current is constant. The reason for the load current is constant because it has two paths. In mode 1 it also have one path to flow through the RLE, and in mode 2 also it flows through the RLE. So load current is constant. Also the capacitor start discharging, so you can see that it rises first and start discharging here. Also you look at the thyristor, it discharges through the thyristor, so it is same at here. Also freewheeling diode is not conducting, so it looks like it is short. Also you can see the Vc is a capacitor, here Vs is the supply voltage, it from rises and reaches to the 0 and then it rises to minus Vs. Also the thyristor Vt1 is conducting, that behaves like an short. Also auxiliary thyristor, which was previously charged, starts discharging here from negative and rising to the positive value. And look at the output value is also constant. So what is the current through the thyristor ITA? That is also 0 because thyristor is short. So you can also see that from the diode, because another path is available here, so it rises and then it falls at the mode 1. So you can see here in the diagram how the thyristor works in the mode 1 and also in the mode 2. What has changed? The change is that the capacitor change its polarity and only path of the load current is available. So you can look at the graph that load current is again constant at the mode 2. You can see here that load current is constant at mode 2. Here the load current is constant. Also you can see the charging current, because the supply voltage equal to the capacitor voltage, so this is you can see that it is 0. Also across the thyristor, which current is flowing through the thyristor? That is load current I naught. Still I naught is flowing in the mode 2, that means it is behaves like an constant. So also you can see that freewheeling diode is not conducting, so here the capacitor is charged with the minus Vs, so here is the negative supply. Also you can see that the voltage across the thyristor T1, it is short, so it is absolute 0. So also you can see that in the auxiliary thyristor in mode 2, auxiliary thyristor behaves like an open circuit. So what you have voltage across it is the supply voltage, only the supply voltage exists across it, so it is with the Vs. What is the output? You can see that again is constant Vs. So what is the across the auxiliary thyristor? It is open circuit, so no current is flowing, so I is equal to 0. In the mode 2, there is no diode conduction, because diode here, how the diode behaves here, diode behaves like an open circuit, so you can see here the diode, the value is 0. So I will erase this first. So you can also again see the graph how it works. So there are various changes up to the mode 2 we have studied. What happens in the mode 3? In mode 3 what happens? Now again, what we have studied, the second way of charging is that from the supply it passes through the capacitor and then the auxiliary thyristor is triggered and it flows through the load. So this is the way the capacitor gets, again it gets charged. When the capacitor again gets here charged, what are the conditions we can see in this graph? So you can see up in the mode 3, here it is the mode 3. So we will discuss one by one. The load current is still constant, because you can see that current has a path to flow, that is supply current has a path to flow, so Is supply current is equal to I naught, so this is absolute constant. Also you can see here the capacitor here is charging with the load current, but it is negative. You can see here capacitor is negative. Also you can apply here KVL then you can also see that here it is negative. Also the thyristor T1 is off, so current in it is 0. So what about the freewheeling diode? There is no freewheeling diode, so it here no freewheeling diode is conducting. So also you can see one thing, that in the mode 2 it is charged with the minus Vs, which is charged, capacitor is charged with the minus Vs. So also it get ramp value, that it rises here. So you can see how it rises because capacitor is charging, so this is value is called as the ramp value. Also the VT1, that is voltage across the thyristor. So you can see that in the third mode the thyristor is open circuit. So what is the voltage across it? It is first half here, it is up to minus Vs, then it rising and reaching the positive value of Vs. Why? Because capacitor is still charging. When the Vs is equal to the capacitor voltage, then it becomes at the here positive. Also you can see then auxiliary thyristor which is short, so it is 0. So main thing here is the output voltage. You can see here the output voltage is minus of 2 Vs, which is very dangerous, and this is one of the disadvantage of this voltage commutated chopper. You can see that already the output voltage is Vs here, and now again you can see it is charged, so it became 2 Vs, which across the thyristor we have to protect always the main thyristor, but you can see the minus Vs minus and the plus capacitor voltage. So you can see that minus Vc equal to 0, so that it is 2 Vs. So the thyristor, across this thyristor T1 there is an output voltage of minus 2 Vs, which is very dangerous for the main thyristor. It rises here, then again it starts discharging. Also you can see here the auxiliary thyristor, that is ITA, the current flowing through it is the load current, so you can see here a ramp, a value. Also the diode is not available, diode is open circuited, so no current flows across it. So you have understood the mode 3. Also I will explain the mode 4. After these things happen, now the capacitor again reverses its polarity. From here it become plus minus. It changes its polarity. Now what happened? This all becomes the open circuit. Also the auxiliary thyristor is off. Here the thyristor T1, that is main thyristor, is also off. Also here the diode is also open circuited. So there is no path for the supply current to flow. So that means the load current at the fourth mode, you can see the charging current rises and reaches the 0 because there is no path to discharge. Also the main thyristor is again, you can see the mode 4 here. At the mode 4 you can see that charging current is 0. Why it is 0? Because there is no path to discharge. Also the thyristor T1 is off, so current is here, it is also 0. So freewheeling diode is conducting. How it is conducting? The load current is flowing, I naught is flowing through that, so it is rise here. Also you can see the capacitor is charged with the voltage Vs, because there is no path to discharge. It is already charged in the third mode with the polarity plus minus, and it has no path to discharge because everything is open circuited, that is main thyristor, also the auxiliary thyristor and the diode path. So in the fourth you can see that Vt1 is the voltage across the thyristor 1. So what is the voltage here across is the Vs, the supply voltage, because this is open circuited. Here you can see at the auxiliary thyristor. Auxiliary thyristor is bit of drop is here. Why? Because of the overcharging. Also you can see that the output voltage is 0 here. The auxiliary thyristor ITA is open circuited, so no current flows through across it. So also in the mode 4 the diode is also not available. So you can see here the 4 modes how it is operated. Also you can see here that this same cycle repeats again and again.